security analyst at Compass Security, which is a company based in Switzerland and Germany. But first, a little bit of introduction of why we decided to participate to the Pwn2Own 2024 as a company. So, well, the answer is easy. We also participate on Pwn2Own 2023, and we target the Synology BC500 camera, and we were successful, as you can see from the tweet from the ZDI team. So that's why we decided to give it a try for the Pwn2Own 2024 as well, which now, starting from 2024, was not held in Toronto anymore, but they moved to Cork. And our team is composed by 5 people. It's composed by myself, then my colleague Yves, Urs, Cyril, and Lukasz. If you're asking yourself why I put this avatar near all names, that's because each one of us inside the company has its own avatar based on some, let's say, characteristics. And yeah, if you want to use them for phishing purposes, feel free to use them. If you want to impersonate me, just use bad English. You don't even need like the avatar. But then let's talk a little bit about the Pwn2Own competition, because I'm not sure if all of you knows what the Pwn2Own competition is. So I will give you some introduction so we are all in the same page. There are few rules which are quite simple. You have like 3 tries or 3 attempts to pawn the device that you have chosen, and each attempt can last at most 10 minutes. If you fail all attempts, basically you have failed the competition. Then your exploit should be fully automated, meaning that you are only allowed to type the command in order to execute your exploit, and then you are not allowed to touch anything else. You cannot, for example, go to the target and unplug and plug it again, the Ethernet cable, or just reboot the target device. Everything should be automated. Then you don't get any credentials. Usually the ZDI team will just buy all the targets, then they will change all the default credentials following the user manual, and they don't give it to you any credentials. So you need to perform like remote code execution as like an anonymous target or an anonymous attacker. And last but not least, all the targets are fully updated, meaning that all the targets are, of course, updated with the latest available firmware from the website vendor at the time of the competition. So you should be ready also if there are some updates 2 or 3 days before the competition. There are different categories, and each category has its own bounty. For example, there is like the security camera category, which has a bounty of 30,000, the NAS category, which has a bounty of 40,000, and you get the bounty, of course, if you pawn them. Then there is like the printer category, the smartphone category, which a higher bounty, like 250,000. And starting from the year 2024, yeah, it was last year. Also, WhatsApp joined the group, and they are giving a bounty of 300,000 if you can find zero-click exploit. And as you might have guessed from the talk description, one of the targets that we chose was the Ubiquiti AI Bullet. And now I'm showing you how we got access to the camera. So we bought the target, and as soon as the target arrived, we decided just to open it, as we did with other targets as well. And the idea was to find some interfaces or inspect the motherboard to see how the motherboard looks like. But while we were disassembling the camera, we felt that the camera was not really intended to be opened, because it was not an easy task. And it required like a lot of brute force, and you can see the results of the brute force on the frame of the camera. There are a lot of scratches around the frame. And the idea was to inspect the motherboard and check for hidden interfaces like UART or JTAG and try to connect to it. And after carefully analyzing the motherboard, we were able to find the only one hidden interface of the camera. So based on that, we decided to attach it to the network and list the exposed services by the camera. And so we just connected to the same network as the camera. We ran Nmap, and we realized that the camera was exposing the port 22, so SSH was enabled. Considering that we haven't set up the camera, we looked online for default credentials, and we found that the default credentials are UBNT and UBNT for username and password. We tried to connect to it, and it worked. Then we wanted to see the access that we got via SSH, and we were already admin. So we already got root access to the camera via SSH. So remember to read the manual first before disassembling the target. And then let's see some exploration. Since we had root access to the camera, we wanted to see all the services that were exposed by the camera. So we executed netstat, and we noticed that, of course, the port 22 was exposed, and the drop bear binary was responsible to handle all the SSH connections. Then there was the port 80 and 443, which is like the standard HTTP server that you can use to just manage the settings or configure the settings of the camera. And then we noticed there was another UDP port exposed on 10,001 by the binary infctld. And after researching online, we noticed that this is some protocol called Ubiquiti Discovery Protocol. Considering that this seems to be some kind of custom protocol, we decided to have a look at it first, just to see if we can somehow find some weaknesses there, since it's like a custom protocol, or it seems to be. And basically this Ubiquiti Discovery Protocol is a UDP protocol that is used to discover Ubiquiti device on the network. And it works like that. Let's suppose that you have a computer connected to the same network as some Ubiquiti devices, in this case like the camera, and you will send a UDP packet composed by this 0, 1 and a bunch of zeros, and the camera will just answer with these 0, 1 and 4 zeros, and followed by some information related to the camera, like the device type, the device name, the IP, and other additional information. We looked online, and we noticed that there are already some other known tools that can implement this protocol. We performed some fuzzing, some quick fuzzing, but we didn't find anything. So we decided to move on. Also because inspecting the binary, it seems that only they were parsing 1 byte, so we felt like, okay, let's just move to another service and hope for the best. We also analyzed the web service that I showed you before, the port 80 and 443. We could find some crashes, but we couldn't change them or find a way to change them together to reach remote code execution. And so without any other options, we decided to look to other services that doesn't really expose any port on the network, but still uses the network to just interact or perform some actions. And we also knew from previous researches that from previous version of the Pwn that the DHCP might be one of the attack vectors. So we decided to look at how the camera is implementing the DHCP request and response flow. And here you can see on the left the DHCP server, and then on the camera there is a binary called UDHCPC, which is responsible for sending the DHCP request to the server and also handling the DHCP responses from the server. So whenever the camera needs a new IP or the lease is going to expire and they need to renew the lease, the DHCP request will be sent by this binary, and of course the DHCP server should answer with a DHCP response. The binary will just parse this DHCP response, and after doing some actions, it will call another script called UDHCPC_CB. And it passes all the information read from the DHCP response packet as environment variables. This script does something, let's say, and then it will just send an IPC message, so an inter-process communication message, in order to notify other IPC-enabled processes about any changes of the network settings. And the message looks like this. It's basically a JSON message that includes all the variable read from the DHCP response. So let's have a look at the script. Here you can see, like, because of space issue, because the script was quite huge, I'm only showing you like the important part. So the command that sends this IPC message. There are some flags like the -m is basically the flag that's responsible to tell the message that will be sent via IPC. So in this case, it's the JSON message that I showed you in the previous slide. And there is also this -b flag, which means that this message will be sent as broadcast. And this, let's say, kind of makes sense because in the end, multiple binaries might be interested in being notified in case of changes in the network. Then, as you can see, there is no escaping. And as you cannot see, because I haven't added pasted the entire code, but you have to trust me, there is no variable validation performed by this script. So let's talk now about a little bit about the analysis, meaning that we had an idea like since there is no validation and no escaping, we might be able to inject some JSON keys into the JSON message. So the idea was just that, to try to inject a JSON key inside the JSON message, but to do so we need to first target one of the DHCP fields. And I'm not sure if you have, or I don't know if you have already read the DHCP specification, but it's quite strict with some fields, like for example the IP and the DNS only has like 4 bytes or 4 numbers. But then there are some other fields like the domain name that doesn't have such limitations. So we decided to set up a DHCP server where the domain value will be something like this. So the idea would be just to inject an additional IP JSON key inside the JSON message sent via IPC. After doing that, we also monitored the IPC messages exchange inside the camera, and we noticed that indeed the additional IP JSON key was injected in the message. After some testing, we also realized that in case like a JSON key is present twice, like for example in this case for the IP JSON key, only the last value is used, or is, let's say, used by the other processes of the camera. And so this means that we can overwrite all the JSON key that you see here in orange. We tried modifying some values like the IP and the subnet with invalid values, considering that now we have bypassed the validation of the DHCP message, but we couldn't find any crash on other binaries handling this message, or anything that could lead to like a command execution. But then we noticed the first key, the function name, that looked interesting, and we wanted to see what other function names were present in other binaries of the camera, to see what kind of actions were supported by the camera. So, for example, there is like this binary, UBNT system CFG, which implements these function names, these adopt and change MVR settings. And then we continue looking at other binaries just to get a list of all the available function names until we started looking at the UBNT CGI binary, which implement the scan API, test and apply network settings, and other function name, as well as the reset to defaults, which looked interesting. The issue is that if we want to call like another function name, we have also to provide all the parameters required to that function name to work, or to that function to work. So for example, if I want to invoke the scan API, I might send the access point name that I would like to scan, or if I want to call the test and apply network setting, I might send the IP, the subnet, and other kind of information that are required, meaning that during our injection, we also have to inject all these additional JSON keys. So we reverse the UBNT_CGI binary to see what should be, or how the JSON message looks like to invoke the reset to default action, and luckily for us, it's just this one. So you have just to inject the function name, and whenever the UBNT_CGI binary processes the message, it will just reset to default the camera. Now I will show you the exploit, and I will explain you like the final logic already, because it's like quite easy. Let's suppose that you are an attacker and you are in the same network of the target, in this case the Ubiquiti camera. The exploit will first perform the ARP spoofing in order to poison the ARP cache of the camera, and so the camera will think that the DHCP server is now an attacker-controlled machine. When the lease of the camera is going to expire, then the camera will send a DHCP request to the attacker-controlled machine, where like a DHCP server is running. This server will just send answer with DHCP hack response message, including the option 15, which in the DHCP protocol is the domain name, and the domain name is set to the string that I showed you before. When the camera processes the message, it will perform the factory reset, and after that, the exploit will try to connect via SSH using the default credential. Now I will show you a quick demo. So let's see. Okay, now you should see here I have a little setup where I have like the router, I have the camera here that I haven't attached yet, but I will attach it now, and you should see some, hopefully it doesn't roll. Okay. You should see some lights around the camera when it boots up. I should get an IP, like in this case, my IP is 200, and now let's see whenever the camera is ready. Oh, it seems to be already ready. And just to show you, if I want to try to connect via SSH using the default credentials, basically I got rejected because the credentials are not correct, and that's the same for the UI. For the UI, you can use two different username, UBNT or UI. The correct one should be the UI, but in the end, the credentials should be still UI. And as you can see, this doesn't work because the credentials have been changed. So now, here I'm going to run the exploit. Basically, it takes like the target IP, the interface I'm listening on, my IP address, and some debug flags just to show you some additional logs. When I run the exploit, you should see some information here at the top, showing like the IP of the router, the MAC address, and other information. And here you see the ARP spoofing, which started, and also the DHCP server, which is starting and waiting for DHCP requests. Here you can see that we received some DHCP requests from a different IP than the camera, so we just skip them. And at some point, whenever the lease is going to expire, the camera should send the DHCP request to our to this laptop. If everything works, so the lease time usually is set, or we set it to like 2 minutes, so it should arrive soon, hopefully. Okay, finally. Here you can see that we received the DHCP message from the camera, and we answered with the domain, with the string that I showed you before, and we stopped both the ARP spoofing and the DHCP server. You should see some lights on the camera because the camera is now rebooting and performing resetting to the default. And now you can see that the script tries to connect to the port 22 with the default credentials. You should have heard a click from the camera. I'm not sure. In case you haven't heard it, click. And now you should see that it's downloading some binaries and HTML file. Then automatically opens the Firefox, showing the page, showing our logo of the company. And that's basically the script. Okay, so now everything was ready, let's prepare for the contest. We booked the flights from Zurich to Cork, and we decided that out of the 5 members of the teams, only 2 of them would go on site to Cork, and the other 3 would remain in Zurich. After some internal discussions, we decided that Cyril and Lukasz would go to Cork. It was calm discussion, we didn't just... It's normal discussion. And then Lukasz and Cyril would go to Cork, and because in 2023 we targeted the Synology camera, and Synology seems to be known to publish updates shortly before the competition, and that's what happened like in 2023. We decided to create a watchdog process that would monitor the Ubiquiti website in order to notify us in case of updates. Shortly after passing the security controls, we received the following message showing that a new release candidate version was released, and so our first reaction was panic, because if that would fix our exploit, then we could just go to Cork at least for holidays. But then the 3 members that remained in the Zurich office tested the exploit, and everything still worked. And sometimes later we received the email from the ZDI team showing all the different versions of the in scope for the competition for each target, and luckily for us this new release candidate was not in scope. Still, with a little bit of panic, we went to the competition, and luckily we were successful. But if you look closely to the tweet that they published, they said a collision. But in theory, all of these should be like 0 days. So what does a collision mean? I didn't tell you that there could be several teams that can target the same target that you want to target. Sorry for the words. But basically in our case, there were like 6 teams that wanted to target the Ubiquiti camera. And in order to select the order, there is a drawing shortly before the competition. So in our case, the first team that got extracted was Stallion, and they were successful pawning the camera, so they got the full bounty. Then it was Synactive, which also was successful pawning the camera. Then it was Antud, sorry for the pronunciation, but I don't know how to pronounce it, and they were successful. And we got extracted at 4th. And we were successful, but the issue is that the exploit or the vulnerability that I just showed you was already used by one of the previous teams. So that's why it's called a collision. And after this positive experience, we have some takeaways that we would like to share with you. So just don't be afraid to start. You will never feel totally ready probably to pawn a new device, but we encourage you to just start anyway. You will figure out stuff on the fly. And then be persistent and don't give up, because I created this presentation with like a logical progression, but to be honest, sometimes it was a mess. It wasn't so logical, and we found a lot of dead ends. Some of them were not even a dead ends, but yeah, it worked out in the end. Be creative in identifying the attack surface, because remember to test like all the services that of course expose like a port, but also look at the one that doesn't really expose any port, but that still uses the network to interact with the network. Ensure that the exploit is stable. Spend some time testing and creating a stable version of the exploit. In the end, you have only 3 tries at the competition. So more stable is the exploit, more chances you have to be successful. And stay quick to adapt to last-minute updates, because usually firmware updates for Pawn2Own drop at the worst possible time. So be ready to test your exploit in case there is a new firmware update. So, because of the first takeaway that I told you, the one to do not be afraid to just start, we decided to also try the Pawn2Own automotive in Tokyo this year in January. And we failed. Basically, in reality, the exploit works. The issue is that we overlooked at something at the competition. But yeah, I cannot really tell you more, because we are still under NDA, but I hope maybe we can create some, it should be like a nice story for another talk. This is like a 30 minutes talk, and I had to cut some details in the end. So, if you're curious or you want to like read more about this topic or the exploit for the BC 500 of 2023 or other like topics that we usually talk about, here you can find our blog. You can scan the QR code, it's not phishing, or if you think it's phishing, there is also the link below, you can just type it. And that's all. If you have any questions, you can either ask now or later.
Any questions?
So where you exploit the DHCP lease and you only have 10 minutes, did you have to tell to the team to set the lease to 2 minutes, or how do you trigger that? Because that wouldn't really be like a real world scenario, because usually DHCP lease is like 12 hours. So how did you get around that?
Yeah, usually whenever you have an exploit, you can tell the ZDI if you need a specific configuration. So we told them we need to exploit the DHCP request and response. Can you set the lease time to like, I don't know, 5 minutes or 10 minutes? Now I don't remember what was. But in the end, you can ask them and they will set it up. Because the idea is just to show the exploit, not really just to, if you need some specific configuration, they can either apply it or not, but usually they won't apply it.
All right, thank you.
Anyone else? All right, and thank you so much, Emanuele.